Hello guys, so today we are going to solve the problem 2.77 in which we are given this diagram. Here we have some inputs and some outputs, and here this is basically the communication channel. Okay, so this problem is basically related to the communication channel and how probability is used in the communication channel to find out different probability, and the main thing we actually are going to use here is basically the Bayes theorem. Okay, so we are going to discuss the Bayes theorem, that how it can be used to find out different probabilities. So a non-symmetric binary communication channel is shown in figure 2.3. Assume the input is 0 with the probability p. Okay, so the probability of input equal to 0, that is p. Okay, and the probability of the input equal to 1 is 1 minus p. Okay, as given here. Okay, this is given here and also here as well. So what we have to do in part A of our question, we have to find the probability that the output is 0. So we have to find the probability of 0. Okay, so we have to find the probability that the output is 0. Okay, so why did I have you use this red color here? So here we are going to use outputs with this red color, while this inputs will be used with this blue color as well. Okay, so we have to find the probability of output equal to 0. Okay, so which theorem are we going to use here? So here, in order to find the output equal to 0, we are going to use the theorem on total probability. Okay, so what is the theorem on total probability? We can see here that here we have this output 0, and this output 0 has been caused by different inputs. If either we will have 0 at the input, or we can also have 1 at the input, and from these two possibilities we can get this output here. Okay, so in order to calculate the probability of 0 here, what we can do? So the probability, this is part A, the probability that output is 0. Okay, so there are basically two possibilities for it. First possibility is the probability of the output equal to 0 given that input is 0. Okay, if input is 0, then what is the probability of 0, and similarly what is, multiply it with the probability that, what is the probability that input is 0. Okay, so this is one of the possibilities that we have. What is the probability that output is 0 given the input is 0, but what is the actual probability of input equal to 0? Okay, so we have calculated it. Or there is another possibility here as well, and that is the probability that output is 0, okay, given that input is 1. Okay, so what is this case? This case is basically the erroneous case, where we are having this link. Okay, so this link is basically showing me this case, while this link here is basically of this case. Okay, this overall case, I mean, while this one here, the probability of input equal to 1, we have also have to find, multiply it with the probability that input is equal to 1. Okay, so what is this overall case basically portray as the this possibility. So now do we have all these values? Yes, we have all these values. So let me put them here. So the probability of output equal to 0 such that input equal to 0, this is this case. Okay, so the probability of it is 1 minus epsilon 1. Okay, and what is the probability of input equal to 0? I have already told you guys the probability of it is already given here, and that is p. Okay, similarly, what is the probability of output equal to 0 given that input equal to 1? What is this? This is this one, okay, this error, and the probability of it is epsilon 2, while the probability of input equal to 1 is this one. Okay, and that is multiplied by 1 minus p. Okay, so that is what, so that is basically the probability of output equal to probability of the output equal to 0. Okay, so that is the solution, and you can simplify it some more, but the answer here is this one. And if you know the value of E1, E2 and P, we can very easily put them here and find out the value of probability equal to 0. So that is due to this theorem, which is called the probability theorem on total probability, which is given here. Okay, so that is for the part A of my question. In part B of my question, I have to find out that if I have received 1 here, what is the probability that the input given here was 0? Similarly, if I also received 1 here, what was the probability that I have received 0 here? Okay, I have received 1 here, I mean there was no error. So for it, I have to use the Bayes theorem, okay, in which the final event has been occurred, and I have to see the cause of that effect. Okay, so what I have to do, I have to find the probability that, what is the probability that input is 0, okay, given that the output is what? Let me have a look here. Given that the output is 1. Okay, so output is 1. I have to find out this probability. So in order to find this probability, I have a Bayes theorem in which I have to write that the probability of output equal to 1 given that the input is 0, okay, and multiply it with the term that what is the probability of input equal to 0. So I have to write here probability of input equal to 0, okay, and divide it over what? Divide it over this term, that what is the probability of output equal to 1. Okay, so the probability of output equal to 1. Okay, so again I have to use the theorem on total probability over 8, theorem on total probability. Okay, so now let me put their values here, and by putting their values I will see that the probability of output equal to 1 such that input is equal to 0. What is that? Output is equal to 1 such that the input is 0, that is E1, okay, multiplied by probability of input equal to 0. What is that? That is here, that is P. Okay, so multiplying it with P and dividing it over this term, where this will be probability of output equal to 1 such that input is equal to 1, and multiply it with the probability of input equal to 1, okay, and adding it with the probability such that output is equal to 1 such that input is 0, okay, and multiplying it with what? Probability of input equal to 0. So, by putting their values, I will see that I will get the value of this term, which is now here. Okay. So, now let me put their values here. So, putting their values here, what I will get, this would be E1 into P, and the probability that output is 1 such that input is also 1. Okay, this one, that is 1 minus E2, that would be 1 minus E2, and multiplying it with the probability that input equal to 1, and what is that? That is 1 minus P, 1 minus P, okay, and the probability of output equal to 1 such that input is equal to 0. This is this one, output is 1 such that input equal to 0. So, that is how much? That is E1, putting value here E1 and multiply it with the probabilities that input equal to 0, and that is P. Okay. So, that is the answer, that what is the probability of input equal to 0 such that output equal to 1. That is the answer of part B. Okay. Similarly, here you also have to find the probability that the input is 1 given that the output is also 1. So, you have to find the probability that once you have received this output equal to 1, okay, once you have received the output equal to 1, which is, what is the probability that input equal to 1 such that you have already received the output which is already 1. So, you have to find its probability. Okay. So, it is again calculated by using the Bayes theorem, and you will see that by putting their values, you will see that which is more probable as compared to the other if you have the values of P, epsilon 1 and epsilon 2. So, it will show you the feasibility of this communication channel. Okay. It will show you the feasibility of this communication channel which we have here, that is the communication channel with parameters epsilon 1 and epsilon 2. Okay. So, that is it for today, in which we have discussed a very important topic of the bit probability estimation from the channel parameters, and we have seen that how to calculate the possible bit at the input if certain output has been received and vice versa. So, we have used two theorems. The first one is the theorem on total probability, while the second one here is the Bayes theorem. Okay. So, that is it for today, and I will see you with some more interesting questions which are related to the probability and random variables. Till then, take care of yourself, and I will see you soon.